Okay, so UI meeting for July 27th, 2016. Okay, so the question of the day is the show and tells, at least the Redux reselect. Is that going to take up majority of the time? Probably.
Yeah, I mean, it depends on how deep we want to go. I definitely need at least 30 minutes to cover everything, but I think if we want to open up larger discussion, Q&A and whatnot, then
Okay,
we
well
want a little more time.
let's just start with the show and tell then. Unless there's something in team discussions that someone's really want to get at.
Impressive for me. So
The biggest thing is just note the second one, the proposal to deprecate the search service in favor of just using Angular's dollar location directly. Anybody feel strongly about that either way?
so there is one gotcha with that, whereby empty strings are not do not like drop the query frame.
The null will.
The null will.
And that's actually useful for at least us in Journeys. It's good to know when the state has been applied, but it's just empty, versus no state being applied and just being default.
Yeah, it does have some consequences for search. So if you clear your search box, then it's considered an empty string, so that the query frame still shows up as nothing in the URI. For this MMF that we're working on, I created kind of like a directive, a trial directive to just that you can apply to an input field that converts null or empty to null. It might be worth you taking a look at later. That way you can compose it into different input fields as needed, but it won't have like a global behavior of treating empty strings as null. So just something to keep an eye out for in the pull request. But beyond that, nothing else.
And that's on your Uber?
Okay.
No, I guess I had to have a question in there whether the directive, having a directive to do that is overkill or not. But, but yeah, that is important to know that when you set with dollar location, an empty string will not remove it from the URL. But conversely, when you set with anything that is considered empty through the search service, it will remove it from the URL, and that has proven detrimental when you're managing state that needs to know about default versus where default is not empty versus a set state that is empty.
Okay. So we should keep this one on there for a future discussion for the time being then? Or are we?
It doesn't sound like there's any blockers to not go ahead and deprecate it. So just moving forward, if you run across uses of the search service, see if dollar location can accommodate your needs, and if for some reason it can't, maybe let's chat about that and figure out a solution there.
Okay. All right, so let's take a look at the Journeys Redux reselect.
Yep. Just running it right now, so I can go ahead and share my screen.
Okay.
All right. So, share all the things. All right, so I think the place to kind of start with this is
Hey, Kai.
Hey.
Would you mind doing the present to everyone? I think that will make sure the recording picks up your screen.
There is no present to everyone on the record mode.
Okay.
And it does say that I am presenting to everyone. But I think by default, Maybe Colin just needs to stop sharing.
Oh, as in myself? Okay, yeah. Your screen stop. My beautiful mug. Okay.
So I think the place to start in diving into this is kind of giving a high-level overview of Flux architecture, and then kind of comparing it to Redux, and then kind of diving into how we're implementing Redux in Journeys, and what it's helped and where some of the pain points may have been. So to kind of orient us to Flux, the idea is a one-way event loop. So you don't really have any magic happening within a component. Everything kind of flows through the same event cycle and gives your state the ability to basically make sure that all events flow through your state, so your state can be persistent and your single source of truth can be realized. And so that essentially means while some controllers may have localized state, anything that needs to communicate across a particular view really should be pushed out and then stored out in a service, which then the controller can watch for changes on and then update the view accordingly. Flux very much relies on the idea of dispatching actions, and basically those actions are descriptive objects that explain what the action is and what the information is that goes along with it. So if there is a change in a drop-down, for example, the dispatch would basically be noted as that change type, and then would contain the value of that drop-down to kind of notify your state stores, or basically what information needs to be stored. In Flux, there are many store services. Basically, each store would contain its own needed logic and updates, and basically stores the values, and depending on what's important and what's changed, it may emit an event. Maybe it changed, or maybe something specific changed. So each store would define its own set of events or subset of events that a controller could then sit and listen to, and basically get the updated state that exists in the stores. So basically, your view ends up only reflecting your state from your stores, and not your state from maybe two-way binding in Angular or whatnot. This cycle works pretty well. Some of the complexities here, there's often a lot of questions about who owns the business logic, because business logic could potentially be done on a controller before the action is created, and then the dispatch dispatches kind of just a clean payload, and the stores can respond to that payload accordingly. Business logic can also exist on the stores to handle that payload and digest it the way they need to. And then potentially there's more business logic on the other end, listening to events to determine then how that state store can be transformed to the particular view state that we need. So there's always that question that teams generally need to answer. Generally speaking, the Flux architecture discusses action creator, which is kind of a helper function that will take a payload and turn it into that action object. Business logic would exist on the action creator, and business logic would exist in the stores. There may be a necessity to have additional business logic in the receiving side in the controller, but not in the dispatch side. So there are ways kind of around that. One thing to note is Flux. Flux was kind of proposed as an architecture by Facebook a couple years back now. It was about 3 years ago, maybe. But it didn't necessarily come with a library that was kind of required. It was just kind of a guideline of like, this is this event loop. We put some sample code together for React, essentially. But you don't have to use any of it if you want to create your own dispatcher and simplify your stores with a simple emitter. Then you can go ahead and do this. So in a lot of ways, it scales pretty well. In that you only need to kind of write the bits that you need, and then if you need something else, you can kind of extend it. But this kind of one-way event loop was a pretty revolutionary way of thinking about managing state within your application. So a few years went by, a lot of different Flux flavors came out. There are dozens at this point of different approaches to Flux, and in some ways that kind of reflects the kind of looseness that Flux brings with it. There wasn't a very strict like, hey, got to use this, got to use that, give this a try, and a lot of different people kind of tried to solve some of the different patterns in different ways, trying to make it as efficient as possible and whatnot. And about a little over a year ago now, Redux came out. It was a developer that was putting together a presentation on state management and hot loading. So the idea that you wouldn't have to reload your JavaScript, you could just literally hot load your JavaScript and all of the state could be digested through that and it would persist. Flux doesn't really give you an easy way of doing that, but Redux does. And the key difference here is that instead of having multiple state stores, your state is actually managed in a singular state store. So you basically end up with well, depending on the size of your application, a relatively large state tree. And that state tree is written or derived by reducers. And reducers are essentially just functions that would run through like array reduce. They take an argument of your current kind of accumulator, and they take another argument of your action, and essentially between those you return the new value, which then gets persisted to state. It kind of runs on the same ideas that there's a controller, at least in our world, we would have a controller where there's a method that would go ahead and dispatch an action, basically pumping a payload through an action creator and then dispatching that action. The reducers all listen to those actions and respond to the actions and payloads and go ahead and create their individual pieces of state, but then ultimately, since they're all kind of part of a giant composed reducer tree, the result of those reducers is the store. So you have a singular state tree, which essentially becomes your single source of truth. It eliminates a little bit of the confusion of, where or how does this information get stored, but it has kind of the same. The shift from Flux to Redux is actually kind of easy because you can take your store logic, turn them into reducers, and then you set up your store to be composed from those reducers, and you end up now, instead of having your multiple store services, you have your one single state service that you can retrieve state from. Redux does come with kind of a default API. There is a redux.js that is encouraged to be used. When we first started down this path in Journeys, we looked into kind of what it would take to kind of write a simpler version that doesn't have all of these methods. But Redux itself is actually quite simple. If we look at the source here real quick, there's a couple functions that it gives you: create store, combine reducers. These are things that you kind of have to have. Create store kind of creates your big object. Combine reducers takes all of the individual reducers and allows them to be all combined. So when the state changes, all of the reducers can be written as just individual functions, but then they kind of come together as one big reduction tree. And from there are just really some small, there's apply middleware, so if you want middleware, there's middleware support. So in other words, when the actions are dispatched before they make it to the reducer, if they are of a certain type, they can be pumped through middleware and further transformed or run. And so it actually turned out that the simplicity of Redux made no sense to try to create something simple anyway. We're not necessarily using all of it because some of the helper functions that come along with it are kind of utility functions that relate to React. But we are probably using 80% of what Redux just gives us in terms of defining this event state loop. So that's kind of a quick rundown. Does anybody have any questions at this point?
Is there a middleware that essentially gives you debugging tools to manage to look at your state and your console stuff?
Yeah, one of the cool things with Redux is there is a default like middleware logger, but there's also an ongoing project around showing your state. One of the nice things about reducers is that you're never mutating your state. You're always creating a new snapshot of state. So if your state does change, you can actually do simple equality comparisons on the objects within your state rather than doing a full, like having to do a deep watcher. So the performance benefit is pretty significant there. But the other piece there is every time your state changes, you have a snapshot of your entire state tree that is unique to that moment in time. And so rewinding is actually really, there are some tools that are out there, some middleware that's out there that you can hook up to it and basically see your snapshots go by and literally click on that snapshot and it updates the state to that snapshot tree and your visuals all kind of change accordingly. So you get time travel, you get hot reloading. The benefits are kind of awesome. And certainly for development and debugging, there are a ton of tools out there to help.
You also get events, something like that too.
Yeah.
That's a pretty strong business value.
Yeah. So there's a lot of
We can't hear that on the phone here.
Sorry. You also get event sourcing out of that, essentially, which is good business value. So.
Thank you. Yeah, and so actually in both Flux and Redux, you would have that benefit because basically every time the dispatch runs, you can easily just write a little hook in that dispatch in your dispatcher to say, log me this event. But Redux gives you the middleware, and I think now the formal Flux release by Facebook also gives you that middleware support, but that's only kind of come more recently. And so it should also be noted that this was not created by Facebook, but it now is very much embraced by Facebook with React because the guy that wrote it, Dan Abramov, got hired by Facebook about 6 months after he wrote this thing because it's de facto standard for React. But it's written generically enough that it can really be applied in kind of any scenario. So good. Any other questions right now?
Yeah, I have one. So every time at every action, you get basically a new object, a new state.
Only if your state changes. So
Yeah, that's true.
yeah, your reducer could just return the current state. So if there's no change on it, you can just return what it currently is, so it doesn't actually change.
So just out of curiosity, you can only use Redux with a rendering engine like Angular or React that actually does the comparing of the previous state with the current one and only updates what changed. Because it would be really difficult to use Redux with Backbone, for example, where when you get a new state, it will be really hard to compare it to the previous one and actually only make the necessary updates, not update all the UI.
Yeah, I think I get what you're saying. It's a little fuzzy on this end, but the Redux store essentially has mechanisms built in to be able to subscribe to the store. One of the recommendations that comes with Redux, though, is to not subscribe directly to your store, but basically write a subscriber to be able to subscribe to individual pieces of the store and only be notified when it changes. Your controller actually never needs to worry about the previous state. The controller would only get the push when the store has registered a change and pushes it out. And that actually brings me pretty nicely to the next bit that Redux that we're using in Journeys, but that Redux supports, which is basically the notion of selectors. And so there's basically a function called reselect in React that can be isolated on its own as well. It does not have a React dependency, even though it is coming from the React repository. And essentially what selectors do are they...
Sorry, Kai.
Yep.
With the reducers, are we using Immutable.js to modify the store, or are we doing some other way to ensure that we're not modifying objects on the store?
Yeah, right now we don't have specifically anything like Immutable in the system. It certainly could be, probably should be, but we are just making sure that we're using things like Lodash assign with fresh objects to ensure that we're not doing mutation. So we have kind of patterns in place to protect ourselves from that, but we're probably getting to the scale right now where something like Immutable would be useful to have in the mix.
Okay, thank you.
So as we get over to the selectors, you'll notice that we've got basically in this chart that I put together, the selectors are kind of between the store and the view. And selectors basically take some of that business logic that I was talking about that would happen on the controller in Flux to kind of figure out, okay, well now this is what my state looks like. I need to figure out how to transform this to the view. Selectors can do just that. They select from different parts of state or different parts of the same piece of state and compose logic together to derive the values that you want for your view. So your controller becomes quite dumb. Selectors are observable, and your controllers can basically observe the result of your selector functions and only respond when those selector functions change. One of the nice things about selectors for performance concerns are they're fully memoized. So one selector may get run a handful of times during a state tree, but only, or a state tree change, but only once will the function be evaluated. After that, the result of the function is the same. and it will only actually trigger the observable when the result of that selector function is changed. So you end up getting a fairly well optimized way to view individual pieces of state without having to worry about business logic in your controllers. So your selectors handle all the business logic, they're fully memoized, and then the controllers just kind of set the values you need for your view. So it basically they become bridges between your state and your view, which is kind of nice at the end of the day. There's the questions of where does my business logic live are quite easier. They're much easier to answer than they were with Flux.
Basically, you have selectors for the purpose of taking the state from the state tree, and kind of to reiterate what you just said, take the state from the state tree, driving or transforming it for the itself. So that means really there shouldn't be any business logic at all.
Right.
So now it's really clear
Yep.
where each of the types of business logic go.
Yep.
You have the selectors for deriving from the state, and then you also have the reducers for the purpose of actually manipulating the state itself.
Right.
Which is awesome. That's
Yep.
very, it's such clear.
So business logic is isolated over on the state side of things and not on the view side of things, which is really nice. And yeah, so just a kind of quick look at reselect here. The idea with reselect is that reselect has a create selector function, and that create selector function takes a handful of arguments and returns a function that takes the state tree. So when you write your observables, the state tree part of it is you're basically observing your state store, and you're passing in a selector, and so that selector will ultimately get the result of the current state from the state store. So to create a selector, you can actually give it other selectors, and then the function, the last argument is always a function that has parameters that are the first set of arguments. So in this tax selector example, he's got subtotal selector, tax percent selector, and then he gets the value of subtotal selector, value of tax percent selector, and he can further modify that. So so this tax selector becomes a function, and you can pass it the state tree, and it will pass it through these other selectors to get these values. And this function will only be run if the result of subtotal selector and the result of tax percent selector has changed since the last time it was run. Otherwise, the tax selector will just return the previous value through memoization. So it's heavily optimized. You can actually nest and compose selectors left and right. We've taken advantage of that quite a bit in Journeys, and it really works well. So before I dive into the Journey-specific code, I do want to talk about one other bit that we've tapped into, which is Redux Thunk. And Redux Thunk is essentially it's middleware that allows an action to be a function. And so a thunk is essentially a function that wraps another function, or is a function that wraps the results of an expression. So it can delay the results of things. So with Redux Thunk, the idea is for asynchronous actions, no longer have to dispatch the start of a request, for example, have that pass through the event tree, have the event tree respond, and say, okay, when this has started, then go ahead and make this request. When the request ends, we pass another event through, and that used to all be handled through kind of the relationship of controllers and action creators and reducers. This now can all be contained in business logic in your action creator, which would be a thunk. So the cool thing about thunks is that they can dispatch other actions. So if I wanted to, if I needed to derive something to determine which action was going to be dispatched, for example, I could, let me see if I can find that here. There's an example here. Well, yeah, so we already have, the get state function, so we're able to access the full state at that time, and based on that state, we could dispatch whichever action we wanted. So asynchronously, that helps because you can just write your requests to the backend as a thunk and have all of the actual actions along the way dispatched within your thunk function. And it basically takes, again, that business logic out of the controller and out, it makes it so it's not spread through your controller and action creators and reducers, and instead allows you to just kind of isolate that logic into a single function. Your controller dispatches that function. For example, you need to, the example I'm going to be showing in a little bit is fetching all propositions. So I need to retrieve propositions from the backend. My event state needs to know when that request starts, when it ends, and kind of what the results were. And if there was an error thrown along the way, then we'll also be dispatching that as an action as well. So Redux Thunk essentially gives us the ability to make business logic before we actually dispatch actions or use the existing state to determine which action needs to be dispatched. So we're using it in the two use cases that we have right now are asynchronous requests to the server, and then we also have visual transitions that need to happen that are essentially timeouts and promises kind of combined together to create, it's one event, but it's staged across time. And so the thunks give us the ability to choose when to dispatch which action. So our state can kind of update, not all at once, but along the way to ensure that the transition visually stays together. So the thunks, it took a little bit to get used to understanding those, but maybe the example, when I go to show the propositions, it'll probably make a little bit more sense. So I wanted to dive into kind of what we're doing in journeys. We've essentially boiled everything into a journey state object to kind of, or the folder to kind of maintain everything. We'll start at the main, at kind of the core state, which is the state store. So in the state store, we're essentially injecting Redux and Redux Thunk, and then the core reducer, which we'll look at next. And the store is created quite simply. We just use Redux's create store. We tell it the reducer that we want to use, and then we're going ahead and applying the Redux Thunk middleware. So essentially, create store takes an argument of a reducer and then an argument of kind of additional things that you want to do to that reducer, which in this case we're applying middleware to. And out of a recommendation from the Redux author, we're not, the store itself, the result of this create store will have a .subscribe on it, but that subscribe will get called every time any piece of state changes, which isn't very useful for us. So we've added this observe, which takes an argument of a selector and a callback function. So with that observe, we essentially are calling the selector with the current state, and if the next state and previous state are not the same, again, this is where the shallow equality works fine, even on deep objects. We go ahead and update, and we basically trigger the callback from the observable with our current state and our previous state. Incidentally, we actually don't have any use cases right now where we need to know about previous state, but I added it in there to kind of be consistent with the Angular Watcher callback API. So it's actually quite similar to that. And then we just go ahead and we're subscribing to the store. So anytime the store changes, we go ahead and run this handle change function. And if and only if the particular bit of state based on the selector has changed, our callback will be run. And then we just assigned that observe method to our store directly, and we return that through the service. So if we look at the important part of the store, which is the state reducer, this is the core reducer. And the idea essentially is we have reducers written for each of the individual pieces of state. We can inject those through Angular, and we can actually just combine them with a fairly simple mapping of this is the property that's going to exist on the state tree, and this is the the reducer that will define the value for that bit of state. Right now on master, we've only migrated these kind of 4 pieces of state, and actually it's only 3 because the custom time period has actually been merged into time period. That's one of the nice things about reducers is you can actually compose reducers with other reducers, so you don't actually have to have a huge top-level tree for more complex bits of state. They can manage themselves but still be spread across individual reducers. And we're going to look at the proposition reducer here in a little bit to kind of dive into more detail. One of the early PRs that came out regarding all of this was a way to reduce boilerplate in our action creators. Because essentially, all action creators are taking a payload and they're defining an object that has a type and a payload. And we really weren't doing much with business logic at all. So over to a different branch where we've just recently updated. So what we've ended up doing to simplify kind of our action set and also demonstrate all of the different actions that are available at this time, we've basically made the ability to create an action map. And so the action map is basically a namespace object that takes individual actions and pumps the payload through a payload creator. And so most of the time that's probably just going to be identity, but for things like asynchronous requests, when we get data back from a server, we don't want full response. We may just want the data, the nested object that actually gives us the response back. So our reducer doesn't need to care about the, what the data set looks like or how to get there. Our action creators are dispatching the right bit of information. And then we can also add some business logic where we're mapping an object to a different, basically this is mapping an array to an object with the right keys. So we don't have to, in the reducer, we don't have to magically look at the 0. We know we can see it as from versus 2. So this has kind of greatly simplified our definition of actions and gives us it also gives us a more concrete, or discrete, I should say, view of the API that's available for our current state. And if we're reading anything in the action map here, what these turn into, this activity order change would be dispatching, it would be just change activity order. And then we've got close activity view, toggle channel activity view, toggle lifecycle activity view. So it kind of reads very organically while at the same time being namespaced and much more separated. There's no risk of namespace clobbering or anything like that. So the other half of that was for the thunks. We have the same idea. So we created this actions factory that essentially, I won't go into this too deeply, this is kind of customized, but we essentially have like transition channel view, and instead of having a payload creator, we're actually passing the thunk to it. So the dispatch, if we were to dispatch transition channel activity view, it would dispatch this as a thunk, and this function, which is defined in another service, would go ahead and get called. And the reducers don't actually see the result of a thunk dispatch; they only see the result of the subsequent action dispatches that happen under the hood. And then our actions factory just knows how to digest the action map and the thunk map to create our action API. So this has reduced a lot of boilerplate for us. Basically, each one of these little object definitions used to take 4 to 5 lines. And so to bring it down to basically one, greatly simplify things. So let's just follow a basic, one of the basic pieces of state that we have, which is the proposition. So our journeys proposition controller now essentially looks like this. There's no business logic in here aside from potentially this on destroy. I'm still considering ways to automatically remove the subscriptions on destroy, but for now we're handling these manually. And essentially there's one method that can be called, which is on select change. So if the user changes which proposition is selected, we're going to go ahead and dispatch that value to the, we're going to pump that value through the change proposition action creator, and then the result of that action is going to go ahead and get dispatched. So when that action gets dispatched, and just to cycle back, look at if we look at our action creators, we have a proposition change. This is the action that's going to get dispatched. It's change proposition. And so we're not transforming our payload at all here. We're taking what we're given, and we're going to go ahead and dispatch that. So if we go to our reducers and we look at our proposition reducer, we can go ahead and see kind of what a reducer looks like. We can define a default state as an object, and every reducer gets passed both the state and an action. State is the current state, not the entire state tree, but the current state that would have been returned from the previous run of this particular reducer. So we're only concerned about and we're only aware of the state within this reducer. And so in this case, the action was change proposition. To save a little bit more boilerplate, a lot of people will define these types, these action types, as constants, and then define those in their action creators as well. That kind of creates, you end up with your action types being separated from your action creators, which is problematic. So part of what our action map works with is also defining the type on the action creator itself. So we have a single source of truth here, where our journey actions can always determine the type based on every action creator that exists in the API. So we get this change proposition. This is what this action was that was dispatched, and we're going ahead and updating our state to basically say our selected ID is now whatever was in our payload. And so the selected ID will change. So at that point, once that changes, to follow the cycle through, the result of this function will end up in the state store. But now, in order to get it to the view, we're going to go back to our proposition. If we go back to our view, we've got some observables here. So we're observing two things. The main one we're concerned about right now is selected. So we basically journey state observe, and our journey's proposition is our proposition selectors. We'll get here in a second, and we're getting basically the property that we defined as selected, and then we go ahead and just set selected, which here we're just binding the result of set selected to this dot selected, and in our template, see are selected here. Right. So we use it in the view, and so Angular will only trigger obviously when these values are changed or updated. So if we go back now and look at that selector, at our selectors, got a proposition selector. Our proposition selector, remember, we're looking at selected. Selected is a selector that we're creating as a result of the collection plus the selected ID. So the two bits of state that we're actually storing on the proposition tree are the collection array and then potentially just the string of the ID of the item in the array that's selected. But in order to actually get the object that is selected, this selector goes ahead and dives through, this is a recursive tree. So it dives through the entire recursive tree, which is defined by the collection, given an ID, and attempts to find the actual object represented by that ID within the collection. This selector, we don't need to actually store the entire object that is selected in state. We just store the simple string, and the selector gives us the ability to grab that. So now we know this, both the selected ID, but we also know the actual selected object from the collection that's defined by that ID. And that's what ends up getting back to the view. The view doesn't care about the selected ID. We don't use it anywhere. We use just the actual selected object. We need to know about the name. We need to know about a couple other things. And so we're able to kind of complete the loop. The selector comes back with that value, and it can get passed down to the view. So we're trying to see if there's any. So we've also got things like summary in our selectors. And again, we know our selected object, so this is going to be memoized. We know the selected object, and we want to just get the name. This gives us the summary. So we now have another component that exists outside of where the proposition is selected, but needs to know about the proposition state. And so this lens summary controller subscribes to the proposition summary and can go ahead and set whatever the value is for the view, and then that can be updated. So these components can be they can exist separately from each other. They don't need to be in communication with each other. They only need to know about, the only thing that they really share is the same state tree. So you can reflect your state at any given time through kind of a single source of truth, rather than trying to figure out, well, how can my proposition widget or component communicate with my summary component that needs to know about a couple other components as well. And so this was kind of the main motivation for why we moved towards Flux, but ultimately got to Redux, and it's actually been quite enjoyable to work with. It's a lot simpler. It sorts out a lot of things, and the answer of where does this go is readily available. That kind of sums it up with a bit of an overview of what's going on. Does anybody have any questions? I know we only have a few minutes here.
One question.
Yep.
Have you guys run, and I think I know the answer to that, but have you guys run into situations where you have different reducers that want to look at state that's exposed by another reducer?
Yeah, so that's like the Flux wait for problem. Yeah. So in Flux, there's this idea of wait for, which basically is that one store doesn't want to update its values until it knows about another store's values. In Redux, the idea of wait for does not exist and won't exist. Reducers are pure. You do have a hierarchical state where one state is derived from another. Then you can set it up as a hierarchy and pump the child as its own reducer into the parent reducer. But if the states are separate, then the answer is really in selectors. So let your state be stored. If you're trying to store the value of something else that is a result of another state, you probably don't need to store that value. You probably just want to derive that value from state. And so your selector bridges your state tree to your view, and you can be sure that your selectors won't fire until your entire state tree has been updated. So you can ensure then that your selectors know exactly what values they need to pass down.
Yeah, so basically, like, you either are gonna have a, really need to consider your, the way you design your state tree,
Right.
or if it's a case like you said, then you just have to.
Yep.
So,
Which is better. The less we store in state. I mean, the general rule is as much as we can derive from state, derive it. But if it's something that just cannot be derived, if it's something that needs to be stored, for example, like the ID, right? We don't want to store the entire proposition that was selected. Just store the ID. We've got the collection, we've got the ID, and based on those 2 bits of information, we can get everything we need for all of our views. So, less is more in the reducers themselves, and then try to derive it from the selectors. Basically, structure your state tree accordingly to make selectors basically make stuff available to the views as needed.
when you start doing it, could be used everywhere now?
Yeah, I mean,
Is it against the law?
I wouldn't say that it's against the law. There is, I guess, one final observation I should make is that there's a bit of a can of worms here. So, because of the idea of the single state tree, we're actually mid-stride right now in journeys. We haven't fully migrated everything over. It's interesting that it is possible to kind of piecemeal migrate some things over. And there are some chunks of code that certainly are going to be harder than others. So we've been kind of picking the low-hanging fruit so far. But there is a question of if we were to start adopting Redux in more places, I think the big question is, should we have a single state store that's at kind of the top of the one application, or do we continue to define the state trees basically at the top of each module or each view in the application? So in other words, do we treat each module as kind of their own little micro app, which we've done in Journeys kind of traditionally due to the complexity of state management in Journeys. But there are certainly other realms that are much simpler that could make things easier here to have them all kind of in one top-level tree. And I also don't know what the implications are of if your reducers can only be loaded from the module. If those modules haven't been loaded yet, I guess the state tree would stay null until those reducers are available. So there's probably a little bit of custom work that would need to be done on that end. But if there are areas where people want to start adopting Redux, I would encourage people to do so. I've found it much easier to use than Flux. I've also found it much more rule-oriented than Flux. There's less questions around it. There's less ambiguity about where does this go, where does this go. And between Redux Thunk and Reselect, we have not run into a use case that we haven't been able to solve. It's a very, very well thought out system, and it's not a lot of code that runs it, which is awesome across the board. But yeah, I mean, I don't know what the answer to that is in terms of like, can we use it now? Is it against the law? I don't think anything's against the law.
I can think of a few.
That wasn't creepy at all.
I said it with a smile.
Pull up the Aqua.
Cool.
So,
This is kind of like, and it's probably a longer discussion, but for right now, it's just where do we go from here, and then.
Yeah.
Yeah.
I mean, I think, keep moving forward. Like, if there's something that doesn't feel like it can be solved easily. I mean, we have a lot of modules that Angular is like more than enough. Just like single controller, maybe a couple services, and you're done. With Journeys, we needed more, and we've needed more since the beginning. Really because of there's so many different things a user can do, and all of that state had to persist somehow.
and we had like multiple components that had to reflect different, basically reflect what the user had done or selected, and trying to manage that state through scope, which is where we started, was doable at first, but just became unwieldy. And then we moved to kind of a very loose flux. It was not strict at all. And it had its set of problems and complexities and its code everywhere. And so this kind of brought a lot more formality to the process. So, you know, one takeaway from Reselect, a Redux thumb. This is one of Dan Abramov's big things. Almost everything he writes. Why do I need this? If you're not sure whether you need it, you probably don't. And I think that is some of the wisest thinking in application development I've heard. So if there's a use case, if we have complex state that we need to manage here and there, I know the tagger is certainly one of those areas.
I think it's, you guys are done with, and we're a little bit, I think we were a little bit more strict with flux.
You have a much stricter
We were a
flux.
little bit, we were stricter,
Yeah.
but I think we still feel some pain.
Yeah. And I mean, I will say, like, I don't think Redux is without pain. There is maybe, I mean, the biggest complaint that everybody has is boilerplate. It's true. There is some handful of boilerplate going on there. We can continue to write things to simplify what our reducers look like. And there's a lot of flexibility there, but there's only so much level of obfuscation. I mean, the actions were a huge area for us that we really wanted to simplify. But aside from that, you kind of do the boilerplate, but at least it's the same everywhere. So it's predictable. You know where everything is. And I think Rob's point of adding the immutable JS is certainly a next logical step to really ensure that multiple developers don't forget to leave that object, that empty object off the front of Lodash assign. Really make sure that the system barks at you if you try to do it wrong. Cool. We're a few minutes past, but any other questions while we're all here?
It's probably one of those things the board might fill up over the next week or 2 weeks with questions as people who dive into this stuff.
Yeah.
Certainly, it's a lot to take in.
And we've got more pull requests coming. We've got a relatively large bug fix that just got finished. That PR is done, but we've got at least 2 more stories in the works. And as we're doing these stories, we're continuing to migrate state from our previous system over to Redux. So in those PRs, you know, ask away, question away. I'm trying to include everybody at least once or twice, so we all get a chance to get our eyes on this more than just once.
Thanks, everyone on the phone.
Thanks, guys.
Thank you.